Now we're going to calculate the overcurrent protection device using a circuit breaker in the primary and secondary of this transformer in figure 20-8B, based upon the primary being over 1,000 volts. Now, reviewing the boxed in information for sizing the overcurrent protection device for the primary side, then notice step one, the math, 500 kVA times 1,000 divided by the voltage times the square root of 3 would produce a value of 69.4 amps. Step two, now we would take 69.4 amps times 600%, selected from table 450.3a because the transformer is in a supervised type location, so we can exceed 300% and use the 600% in this type of design. Now, step three, we would take 416.4, and notice there's the note 3 to table 450.3a doesn't allow a round up size, so we'd round down to 400 below the 416.4, and the selection again would come from table 240.6 just to make it as simple as possible for the user of Stallcup's Electrical Design Book, Volume 2. Now, for the secondary side, then step one will be a little different. We'll take 500 kc mil times 1,000 times 480 volt now times the square root of 3, and we have a value of 601.7 amp. From the table now, 450.3a, we would select 250%, and 250% of 601.7 will produce, say, 1,504.3 amps. Now, again, the note 3, the table 450.3a, does not allow a round up, so we round down to 1,500. But now notice, in the non-supervised location, for the secondary, it'd be 125%. But in a supervised location where the transformers maintain, proper maintenance is performed, then we could use the 250%, but we couldn't round up. We'd have to round down from the 1504.3 to 1,500. So the solution is a size overcurrent protection device for the secondary side is 1,500, but for the primary side is 400 amp. So that's what this illustration 20-8B is illustrating.